The Double-Slit Experiment Unraveling Quantum Mysteries. What if I told you that the universe might not work the way you think it does? Imagine firing particles at a wall with two small slits. Intuitively, you'd expect the particles to go through one slit or the other, right? Well, welcome to the mind-bending world of the double-slit experiment, where reality and intuition don't quite match up. Before we dive into the experiment, let's take a closer look at light itself. Light is a form of electromagnetic radiation that we perceive with our eyes. But on a fundamental level, light is made up of tiny particles called photons. These photons are subatomic particles, meaning they're smaller than atoms, and they have some very interesting properties. One of these is their wave-particle duality, meaning they can behave like particles and waves at the same time. In the 1800s, a scientist named Thomas Young wanted to see if light behaved more like particles or waves. He set up an experiment with two small slits and shone light at them. What he saw on the screen behind surprised everyone. Rather than two bands where the slits were, a pattern of multiple bright and dark bands appeared, called an interference pattern. This pattern looked exactly like what you'd get if you shined two waves through the slits, which interfered with each other and created this pattern of peaks and troughs. So what does this mean? It suggested that light was behaving like a wave, but remember, light is made up of photons, particles that carry energy. Photons themselves are small subatomic particles that, strangely enough, travel in waves. They demonstrate what we call wave-particle duality, a concept that applies to many subatomic particles in quantum physics. In this experiment, photons seem to behave more like waves, leading to the interference pattern. Now, here's where things get truly strange. Scientists tried the same experiment with particles like electrons. Electrons are particles that make up the subatomic world, and they are part of atoms, which make up everything around us. You'd think firing electrons one at a time through the slits would leave two marks on the screen, just like pellets going through two holes. But instead, the electrons created the same interference pattern we see with waves. How could this happen? Particles like electrons aren't waves, so they shouldn't form interference patterns. It seemed as though each particle was somehow going through both slits at once, interfering with itself, as if it could be in multiple places at the same time. To solve the mystery, scientists decided to add a detector to see which slit each particle actually passed through. But as soon as they did this, the interference pattern vanished. The particles began acting like individual particles again, as if they knew they were being watched. This baffling behavior showed that on a quantum level, particles like photons and electrons have a dual nature, behaving like both waves and particles. But here's the twist. They seem to choose one of these behaviors depending on whether they're being observed. This phenomenon has led to fascinating questions about the nature of reality and the role of the observer in quantum mechanics. The double-slit experiment is more than a quirky science trick. It's a window into the fundamental nature of the quantum world. This experiment has shown us that particles exist in a kind of probability cloud, where all possibilities are present until they're observed. It's as if the act of observation itself influences the physical reality. Scientists still debate the full implications of the double-slit experiment. Does reality only exist when it's observed? Are there hidden variables we haven't discovered yet? Or could there be parallel universes where each possibility plays out? The double-slit experiment is a beautiful reminder that our universe is far stranger than we can imagine. Whether you're a scientist, a philosopher, or just someone curious about life's mysteries, the questions raised by this experiment are some of the biggest we can ask. So next time out you see a ray of light or think about the nature of reality, remember, in the quantum world, things aren't always as they seem. If you enjoyed this dive into quantum physics, don't forget to like, subscribe, and share. Stay curious, and I'll see you in the next video.